So in today's lesson, we're going to be talking about unit conversion. But before we begin, I just want to get your thinking juices going, and I want you to brainstorm. What are some situations you might face in your life where you need to be able to convert from one unit of measurement to another? Right? So think about, situations you've been in or could be in where you might need to be able to convert from one unit to another. Well, I'm hoping when you think about it that some of these ideas came to mind, and if you have others, I'd love to hear about them. Money. So if you travel to another country, there is a high likelihood that they will have a different denomination that is used for making purchases. So one good example, many Canadians travel to the US either for holidays or simply shopping. And so understanding how to convert from Canadian dollars to US dollars would be important as a consumer. Travel. So if you're traveling in a country where the unit of measurement for distance is not the one that we use in Canada, typically the kilometer, you might want to know an alternate unit and to understand that difference. I'm a runner, and so I know when I'm running, some of the workout regimens list the distances in miles, and so I need to have an understanding of what that might mean in kilometers. Construction. Many of you may have taken construction in high school or will take construction, in which case often the measurements are given in inches and you need to convert to centimeters, or for instance, maybe meters to feet. So at the end of the day, having an understanding of unit conversions is important, not just for science, but for life as well. And so it comes up in science because there's a lot of measurement that we do in science when we're doing experiments, and sometimes the units don't always align in the way that we want to. So let's explore this concept a little bit more. So I want you to understand that I've taught this for a long time, and so I want you to just trust in the method that I'm going to teach you today about how to convert units, understanding that the examples that we're using today are going to be quite simple, but they'll eventually evolve as you move up through the grades to be more complex questions. So we want to scaffold this well for you, and we want to help you learn the idea using some very simple examples. So in the same way, typically when you're in grade, I want to say in elementary school, grade 7 possibly, the first way that they start to teach you algebraic equations is by using what we call the guess and check method. And so a good example of that would be 2x equals 10. And so we would say to you, well, what does the value of x have to be so that when we multiply it by 2, we get 10? Well, we can guess and check that. And the reason we teach you that is because we always want you to consider the reasonableness of your answer, right? Like, why does my answer make sense? So we start with guess and check. And another example might be y plus 7. And in this case, we know that the only possible answer for y has to be 3 because 3 plus 7 equals 10. Now, the problem is that sticking to guess and check is, sticking to guess and check works great for simple problems, but it doesn't work great when you're dealing with more complex problems. Let me give you an example. So once the problems that you get become more challenging, then you need new strategies to make that solving more efficient. Now, let me give you an example. So let's say I looked at, and this is a pretty typical grade 9 math equation that you might have to solve, and possibly even grade 8. And so could you guess and check what the value of x has to be in this? Absolutely you could. But I know certainly that if I have some basic understanding of algebra, that I can solve this much more quickly. Here's another example. And we start to, especially when we get into decimal values for coefficients and answers, the guess and check method starts to become less and less efficient. Could we use it? Yes, but it's not always the most efficient way to go about solving. So in the same way, we're going to start you off today by teaching you a process called dimensional analysis. And it's a method for unit conversion that I wouldn't necessarily use for simple problems. But in order to learn the lesson, quite simply, we're going to start you with some simple examples just to get you used to the method so that eventually when you get to more complex problems, you have some strategies. Right? So in order to make unit conversion more efficient in more complicated scenarios, we're going to teach you a systematic approach. And that systematic approach is called dimensional analysis. And again, we're teaching you this using simple examples just to get the method across, even though it might be more, maybe more efficient to not use a method. Understanding that moving forward, you will have to you'll have to convert units that are much more complex. So let's get started. So dimensional analysis, before we begin, requires that you have an understanding of a couple of things. And the first part is that you have to know the relationship between the units that you're converting, right? So you have to understand, for example, if I say the prefix kilo, that means 1,000. So if I said to you, I want to know what the equivalent number of grams are in 1 kilogram, the kilo there reminds me that there are 1,000 grams in a kilogram. And so the fact that I've used grams as my base unit doesn't change the fact that there are 1,000 of them. I could change that unit from grams to other units. So let me show you what I mean. If I said kilometer, that prefix kilometer means 1,000 meters, and so on and so forth. I could say kilo seconds and, kilo pascals and many other units. Okay, in the same way, centi means 1/100th. So one way to think about this is I know that there's 1/100th of a meter in a centimeter, or there are 100 centimeters in a meter. And that's typically, a unit that you understand the relationship between. We see that quite often in elementary school. Milli is a prefix that means 1/1000th, right? So I could say that there in one millimeter, I have 1/1000th of a meter, but it's easier to think about there being, 1,000 millimeters in a meter. So, 1 second is 1,000 milliseconds, for example. 1 liter is 1,000 milliliters. So, to use the method we're going to learn, you have to have an understanding of the relationship between those units. The second part that's important for you to understand to use the dimensional analysis approach is just some basic algebra. So let me explain this because this is a little bit tricky. If you've taken math, this may seem easier for you, and if you haven't, just make sure that you reach out and you ask for clarification if you need it. So let's say, for instance, that I wanted to multiply a by 1/a, right? So I can think of this first a here as a fraction over 1. So imagine this has a fraction over 1. Then, multiplying fractions, I multiply numerator with numerator. So a times 1 gives me 1a, or just a. Okay, the one that's underneath this a right here times a just gives me a. And I know that anything divided by itself gives me 1, right? So just like if this were a 2 and a 2, that would divide out to give me 1, right? So another way to think about this is that when I have variables that are on opposite sides of the fraction, one in the numerator and one in the denominator, even though they might not be placed one above the other like this, they cancel each other out, okay? And so they'll cancel each other out and then be gone, and that'll leave me with the 1 there. So that's an important concept, but we'll reinforce that through some practical examples. So let's go through a few examples to just help me break down the method for you. So let's say in a particular question, you are asked to use dimensional analysis to convert 250 meters to kilometers. Now again, I know how to convert these quickly and easily, but again, the point of this is to show you the method so that you can utilize it for more complex examples. So let's take a look. So here's the setup. What you do is you start with the unit that you have. So I have 250 meters. right? And then, I tend to go over here and I'll write, well, what is the unit I want to be left with? Well, I want to be left with kilometers, right? So I'm going to write kilometers over here. So I know that I need to get rid of my meters and be left with kilometers. So that's how I'm going to set up this next factor. So I'm going to set up a factor so that I can cancel out my meters. Well, I know from the last part of what we talked about that the only way I can cancel out meters is if they're on the opposite side of the fraction. And so by putting my meters down here, I know that the meters will cancel. And then the unit that I want should always be in the numerator on top here. And so now I'm just going to simply write out what the relationship is between my units of kilometers and meters. Well, I know, and you're not expected to memorize these. If you don't know them, you'll have access to these. I know that in 1 kilometer, there are 1,000 meters, right? So now taking a look at this, I can see that mathematically, a meter will cancel with a meter, and I'll be left with kilometers, right? But so now you might be saying, but how do I work all of this business out to get my answer? Let me try to explain that. So in math, when we're working with fractions, we multiply numerator with numerator, and we divide out if it's in the denominator. So in order to work this out, I would go ahead and I would multiply my numerator with my numerator. So in this case, 250 times 1. And then anything that's in the denominator indicates that I'm dividing. That's a division, right? So in my calculator, I would be writing 250 times 1 and then divided by 1,000. And that will give me my answer. And so your answer that you get if you type that into your calculator should be 0.25 or 0.250 kilometers. And so that's it. That's the method. So just to review, I want to make sure that I have, units that I want to cancel on opposite sides of the fraction. And the unit that I want to keep should remain once I cancel out the other units. I'm going to multiply numerators with numerators, and anytime there's a value in the denominator, I want to divide. So the next example I'd like you to try on your own. So pause the video, give it a try, and then when you're ready, resume the video and then give it and then check your answer. Here it is. Okay, so I'm going to go through this with you now. So I see that in this case, I am given centigrams. That's what the CG stands for, centigram. And so I want to get rid of centigrams. So I'm going to multiply by a factor where my centigrams are on the opposite side of the fraction. And that way they'll cancel. And the unit that I want is going to be the one remaining, which are grams. Now the prefix centi, remember, means 100. So that gives me the factor that I need to relate. I know that there are 100 centigrams in 1 gram. In the same way that I know that there are 100 centimeters in a meter. Okay, the fact that it's grams is just telling me what the unit of measurement is as opposed to what the prefix is. And so when I work that out, I can see very easily that my centigrams will cancel out, and I'll be left with units of grams, which is my desired unit. And so I'm left with grams here. So in my calculator, I want to type out 45 times 1. This is a step, by the way, you can omit because multiplying by 1 is not going to change the value. But then I'm going to divide by 100. And that's going to move my decimal place back twice to give me 0.45 grams. Hopefully you did okay with that. And if you struggled, again, make sure that you reach out. I'm going to give you two more examples for you to try. So I want you to try this next question just to make sure that you're on the right track. Okay, I am going to take this question up. So I have 0.028 liters. That's the unit I want to get rid of. So if I want to get rid of liters, where do they have to go? On the bottom. And so the units that I'm looking for in this case are these milliliters. So they're going to be in the numerator here on top. And now I'm going to write in the relationship between milliliters and liters. And I know that 1 liter will have 1,000 milliliters in it. And so let's just do my unit analysis here. My liters will cancel. I'll be left with liters, which is what I am looking for. And I'm going to multiply across, and then I'm going to divide below. So my calculator input should be 0.028 liters times 1,000 divided by 1. This last step we can omit because dividing by 1 is not going to change my value. And so what you should get at the end of that is multiplying by 1,000 will move my decimal place 1, 2, 3 spots. So that will give me 28 milliliters. And I am done. Hopefully you did okay with that. One last question. So again, I'd like you to pause the video, give this a whirl, and then come back when you are ready to take it up. So I wanted to see how you'd maneuver with this. Because we didn't discuss this explicitly, but you do understand the relationship, hopefully, between minutes and seconds, and that should help you out. So I have 0.60 minutes, and I want that to seconds. So I'm going to get rid of my minutes, pardon me. And so, you know, them being on the opposite sides of the fraction will eventually allow them to cancel out. That's my thought process. And so I want to keep seconds up here. So what's the relationship between minutes and seconds, right? Well, I know that 1 minute has exactly 60 seconds in it. And so, you know, looking at my unit cancellation to make sure that that's on track, minutes are gone. They divide out and I'm left with seconds. So now I'm simply left with multiplying my 0.6 times my 60, which should give you 36 seconds. And I am done. And that brings us to the end of our video on unit conversion. I would strongly suggest that you take a look at the practice worksheet and answer key to monitor your own learning of this very important concept. And if you are struggling, I'll be more than happy to arrange a Zoom meeting so that we can work this out together. Good luck.